Hello, I'm Jim Carr, the StereoBit project PI. I want to thank ESTO for their support under the AIST program and recognize my co-investigators and collaborators. Our work is in partnership with Goddard, and Dr. Christopher Wilson is the Goddard Institutional PI. Dr. Dong Wu of Goddard and Mr. Matthew French, also a speaker in this session, are co-investigators. Dr. Michael Kelly, who's the Instrument Incubator Program PI, is a collaborator. Our StereoBit project develops an application for the SpaceCube family of hybrid CPU FPGA space processors to address high-priority decadal survey objectives. Our goal is to advance onboard processing capabilities that will be critical to enable future Earth science missions. We do this by working a concrete example from start to finish, with the end products being near flight-ready code and lessons from our work to share with the community. StereoBit exemplifies a new observing strategy, leveraging multi-platform distributed observing, onboard intelligence, and hardware miniaturization to deliver high-priority decadal survey science, in this case, resolution of winds in 3 dimensions within the atmosphere, from the planetary boundary layer to the tropopause. StereoBit observes clouds in motion coordinated between platforms and applies structure for motion methods to measure parallax and displacement in time with subpixel precision and thereby resolve wind coordinates in 3 dimensions within the atmosphere. A StereoBit observing constellation can fuse observations from low Earth orbit or LEO satellites and operational geostationary satellites, as well as tandem observations by pairs of LEOs. Each individual LEO produces 3 continuous strips of imagery, looking forward, nadir, and aft. A challenge with high-resolution multi-angle observing at a global scale is the sheer volume of science data. Traditional observing approaches would collect all science data and process it on the ground in a centralized facility to create the science product. We employ a different strategy, disaggregation of science data processing, to perform science data processing on board and thereby reduce the volume of data to be downlinked to the ground without sacrificing science quality or limiting the geographical extent of science observations. Our science algorithms derive from our StereoWinds work, fusing data from NASA's MISR instrument and NOAA's GOES weather satellites. An example product created from MISR and GOES is shown on the right, where the color coding represents the wind height and the vector scale in proportion to the wind speed. StereoBit leverages ESTO technologies integrated into a system to deliver high-value decadal survey science. SpaceCube is our computational engine. Its CPU FPGA architecture is well suited for highly parallelized computer vision processing. We model the instrument data after CMIS and exploit code synthesis and constellation simulation capabilities developed in other AIST projects. We developed StereoBit in an application development test bed, where it is tested with MISR-derived proxy data under flight-like scenarios, fusing observations from multiple platforms and simulating the coordinated observations of a constellation. Our development process seeks to optimize the efficient migration of science code to run on the SpaceCube hardware. Science code is first prototyped typically in MATLAB to run on a general-purpose computer where science verification is most efficiently done. It's then translated into a C language baseline and profiled to identify where FPGA acceleration can be beneficial. Algorithms for the FPGA are synthesized using the Xilinx Vitis tool, then tested. High-level synthesis is a productivity multiplier, and it obviates the need to program the FPGA at a low level using VHDL, for example. The graph at the right shows the results of testing the StereoBit geolocation algorithm on a development board. We're only a quarter way through our project, but we'll have an initial implementation of StereoBit in a few months. We look forward to sharing our experience in future forums and publications.